How to do that, we change a little bit more. Potential. Proximity, as I wave my hand, you see the proximity potential changing reading. The PC Espresso. So when you install all those files, on the 5 steps I showed on the previous slide, so this is what you get. So you, on the navigation pane, you have all those folders, the description of what I provided before. So you can just compile it, debug it, flash it to the board, and it's ready for you to use, and you can get started using just a simple interface.
Welcome to Artecon and to this first of NXP's presentations today. My name is Andy Beeson, and I head up the team within NXP responsible for the LPC Espresso IDE, which is what we're going to spend the large proportion of this presentation talking about. So LPC Espresso itself, as we'll see, is made up of a number of components. We're going to have a few slides to start with, which will just give you a basic overview of the boards and the IDE. And then the majority of this session will actually be spent doing a number of demonstrations showing the IDE in real use. So we'll start off with just giving you a quick overview of some of the functionality and usage, and then concentrate on two of the advanced features within the IDE. First of all, the support for multi-core projects and debugging of some of the MCUs NXP has got, which combine Cortex-M4 and Cortex-M0 CPUs. And then we'll look at some of the advances we've been making in the subject of SWO trace, which is trace functionality on Cortex-M3 and M4 parts that allows us to get various bits of information off the target in real time. So the IDE, well, LPC Espresso ecosystem is basically made up of two main parts. First of all, we've got the boards, such as the one we've got projected on the start of the desk. So many of them look like this, which are produced in collaboration with a company in Sweden called Embedded Artists. And then we've got the IDE itself, which is our software development toolchain. As part of this, we've also got access into our LPC Open software, which is basically our peripheral drivers and middleware and examples. We'll see a bit more about that in a minute. And one of the key things about LPC Espresso is that it is intended for use for evaluation, prototyping, and development. So you can start off by just doing evaluation of an MCU, carry on using the same debug tools, project management, software, right through to your production. It's also not a closed system, so we've not designed LPC Espresso so that it only works with NXP stuff. So we've got a lot of support in there for third-party tool chains, for the boards, for the vendors' debug probes, and also middleware. And our aim is basically to make it as simple as possible for you to develop solutions around LPC MCUs. The LPC Espresso boards have gone through a number of generations now, and we're now up to version 3 of our design. So the original boards got released back in 2009 and were quite a short stick in shape. We've now moved to a bit more of a rectangle, larger rectangle. Some of the features on these, so we've got a built-in debug probe. So there's actually two MCUs on the device. So we've got the debug probe MCU down here at the bottom left-hand corner, and then the main target MCU up here. And the debug probe that we've got on here is based on some technology we've got called LPC Link 2, which is available both built into our eval boards and also as a standalone board in its own right. So a Link 2 in standalone form there. Basically the idea is that you start off by debugging the MCU that's on the board itself, and then once you've got your own hardware, you can change a couple of jumpers and switch to debugging a target MCU on your own board itself. The debug probe firmware is normally for us is Synthesis SNAP, but we also have a J-Link variant of firmware available. So if you're a fan of Sega's J-Links, you can actually make use of some of their tools with our LPC Espresso boards. Some of the other stuff we've got on board, we've got a tricolor LED, which we'll be seeing in action shortly, and then we've got things like user switches, and we've got multiple expansion options as well, which do vary a little bit between the various boards. But the key ones, perhaps, these days are the Arduino Uno Shield style connectors that we've got on the top and the bottom of the board. So you can take an off-the-shelf shield, or NXP has also got its own general purpose shield, so just a little shield which enables you to access things like SD cards, small screen, and so on. All of our boards are provided with our software drivers, so LPC Open, and you can get a lot more information on the boards themselves from the link at the bottom of this slide here. So LPC Open, our array of software drivers and libraries, is basically intended in giving you a driver for each of the various peripherals that exist on a particular MCU, and then at least one meaningful example showing how that driver can actually be used. Wherever possible, it uses common APIs to ease porting of software between device families, and it's thoroughly tested and maintained, so you should have a high level of confidence that you can use this software both for evaluation and in the development of your real products. As part of LPC Open, we also provide various commonly needed third-party